Okay, so we are week 15, day 3. This week we've been learning about nested models in Django and how to handle our CRUD methods with that. We've covered create on the first day, or no, we did CRUD or the create on Tuesday. And then we did I think that's about it, right? We just did create. Now we're looking at update and delete. Oh, we did read. Sorry, read was the first day with our get, learning how to just get all that information. So we've done the read and the create, and today we're picking up where we left off, and we're going to do update and delete in our Django REST framework. So this whole time we've been learning, should have learned last class how to overwrite the create method or overwrite the built-in methods. Do we exactly understand what's going on there when we do this, or no? Can somebody tell me why are we writing out a create method here? Why can't we just leave it like we did before? Anybody know? Well,
Was it because initially the move data only gave an ID number, and in this we're trying to recreate it so we can actually have the move data that says the move and everything associated with that move in a JSON format instead of just an ID number.
right, yes. So we saw that the built-in methods with this model serializer didn't seem to handle our data like we wanted it to. It was giving us just back the IDs of the associated object, and we really wanted to see the data. So we're having to overwrite that. We can also take a look and go into our model serializer, which this is the default that you get. Look, and we can read this little blurb here. So you have a set of default fields, you have a set of default validators, you have a default create and update implementation. However, down here you can see that this, wait, where did I read it, but now it's gone. Where do we see? Doesn't generate a set of extra fields. Let's keep scrolling. I saw it somewhere. Here we go. Okay, so I'm coming down, I'm looking at this create method. Because I wanted to use this, but it's not working how I thought I would. And I can see down here that the default implementation does not handle nested relationships. So if you want to support writable nested relationships, you have to write an explicit create method. So it tells us that in the documentation within this default model that we're using. So that's how we knew that we had to do this. So we had to do it for create. And if we come down to the update, let's see. So there's some special notes here, but we also need to overwrite the built-in method because it won't handle the nested relationships like we want it to. Because when I hit an endpoint, if I say I want to make a Pokemon, I want to hit one endpoint and I want it to create everything all at once. I don't want to have to create a Pokemon, then hit another endpoint to create the move, and then associate that back to the Pokemon. So this does it all in one. Let's move on, and we are going to now focus on doing our update, overwriting, how we are going to do our update. So I'm just following the README for today, which will give you the examples. We're going to walk through how we're doing this update. Let's see. It's a long chunk of code, but we're going to walk through it here. So first thing we do is define our update. We have to name it update because remember back when we were first learning OOP and class inheritance and all that, we're inheriting from the model serializer, but any method we write underneath this class here will be used instead of the parent class's method. So we are using our own create method instead of using that one's. Now we're going to use our own update method. So for this update, we're going to take in an instance and we're going to take in some validated data. And with that, we're going to remove this validated data pop is going to pull out the moves. And we did that up here. We went ahead and took out the moves information in the information we're providing in our, let's see. So with an update, what kind of request is this to the API endpoint? We have get, post. What is update? What kind of request is that?
Is it a put?
Yep, typically it is a put request. So with that, in order to make this put response, we're going to have to, like our create, we're going to have to do something with the Pokemon and the moves separately. So we're taking out the moves and we're assigning it into its own variable so we can handle it separately from the rest of the Pokemon. And because we already have a Pokemon created, we are going to get the instance of that Pokemon, which would be mostly the ID. We're going to pass it in and then go ahead and save the name of the Pokemon. We're going to, let's see, validated data, get name, instant.name. Okay, so here we're going to do a get where the name matches an instance of Pokemon name. If that makes sense. And then we're going to save it. I might need to do some looking into it to explain exactly why we're doing this here, because I can't remember off the top of my head. It might come to me as we move further through this method. Let's see. If anybody else can tell what it's doing here, then feel free to chime in what you may think it might be.
What do you mean instance.save? Why it's doing that?
Yes, why we're grabbing, let's see, our instance name is going to be the validated name. Oh, I know what it's doing. So in this case, we're only going to be updating the Pokemon name if we update anything in the Pokemon. That's how this is written. If we wanted to update more things in the Pokemon instance, we can add it up here because this validated data is what we're going to send in our request. We're going to, let's see if I can come up with it. I'll pull up the README, the example. So we're hoping to do a put request. Let's say this is what was already in the database. We want to change out, what do we want to change? Oh, this is what was already in the database. So it's Bulbasaur, he has a tackle and a vine whip. We want to be able to hit this endpoint and like alter the information a little bit and save that. So as it is, we are only telling it we can save the name of what we pass in. We can also add in the level, but we would do that underneath. We would do an instance.level equals validated data dot get, and then we'd pass in level and instance.level. That is the setup for how to save the instance of the Pokemon. Because we're already passing in the Pokemon that is currently in our database. That's our instance. And then validated data is what we're going to give it next with the changes. So the change here is we wanted to change vine whip to razor leaf. So we're not passing in anything different up here, but we are just kind of reinforcing that Bulbasaur is the name. So that's going to get assigned to this instance name, which the instance should be already Bulbasaur, and it's going to save it. Is that making sense a little bit? If not, just kind of recognize the pattern here. And you can use this for all fields that come with the Pokemon model, because we again, we're in the Pokemon serializer. So we have name, level, moves, and captured. We've already pulled out our moves data. So validated data is this whole thing we're passing in. We initially take out moves. We're popping it out and just holding it in this variable. And then the rest of the data will go through and assign. It looks like we're only going to go ahead and assign it to the name of the instance we pulled out, and then we're going to save that instance. So if I changed it, if I sent in a different name here, it would take our instance, which is Bulbasaur. It would pull the name I sent in and assign it to Bulbasaur's, overwriting Bulbasaur's name, basically. And then we save it because we're overwriting it. Is it a question, Sean?
Yeah, I'm just like, so in the update instance, is that whole object? Like it starting from there, instance in the argument that's being passed is the whole object, correct?
Yes, this is going to be what's in our database currently.
Right. So that whole object there.
Yes,
And then validated data being passed in, is that also the whole object?
it will be. We'll play with this and see what you do with this
Yeah.
method. But yes, we will. This is what we are going to actually send in our body of our request. We're going to send in the whole spiel here. Every key value pair, and then even the nested moves key value pairs.
Because it's almost like we're not changing anything. We're just saving instance name is the
Here,
name of that instance. It's just saving Bulbasaur as Bulbasaur.
yes, exactly. But it's doing that in case you do send in a different name. But right now, the way we have our method written
Oh, the validated data is the data that you're passing in, the headers, right? Was it no, not the headers?
in
It's
the body,
the body. That's right. Okay. So if
yes,
you had name in there, name equals, I don't know, one of those other grass Pokemon,
yes,
then when you run the instance name equals validated data, get name, it would change it from Bulbasaur to a different.
correct.
Okay, I see what you're saying. So that's just in
100%.
there as like a catch-all.
Yes, exactly. So typically, if you are having an actual update method that you want every single field editable, then you would add every field in here. So I would add the level as well and let you alter the level. But at this point, this method is only letting me edit the name of the Pokemon.
I'm tracking.
And that's all we'll do for now to save time. For now, at the beginning here, all we're doing is saving the name of the Pokemon. Moves is different because moves is our nested model. So we can't just save moves. If we did, we'd have to pass in a number. We'd have to be able, figure out what ID is attached to that move that we want to save to this Pokemon. But if that move's not created yet, well, then we have an issue there too. So we need to take the moves out and just hold it for a minute. So we deal with our Pokemon first, we update our Pokemon, and now we're going to create a list to store the IDs of incoming moves. So this helps us disassociate any existing moves that are not included in the update. So we're going to go through the moves for each move in moves data. So remember when we looked at our README, it's going to go through, yes, here we are. It's going to go through this. It's going to say for each move in move data. So it's going to come to the first move, tackle. Okay, we're going to take that move and we're going to update or create. And then we're going to get the ID. Let's see, what is this? This is telling us what it's doing. So we're going to try to get the ID from the move data. So if we pass in an ID with it, it'll try to get that. If no ID is present, it will default to none. So then it will use this information, default equals move data, so it will move the data in there to update or create the move object. So here, if it can get an ID, it's going to update. That's what this does. It tells you you can update or create. So in this step, you're saying the ID is going to equal, if I can find that ID somewhere in existing moves, get that object and that ID and save it. Otherwise, if it's not there, default to none. And if it's none, it's going to create. If it gets an ID, it's going to update. So another little syntax we can just look at here. It doesn't really tell us much back there on what it does, I guess.
Is this a built-in method?
This is, yes. Yep. This move or this update or create is a built-in.
Okay.
It is definitely not something I wrote. It's under the basic query sets, so everything we were doing with our like get or our .all to pull things from our database. It's another built-in method we could use on that data this time now to save it, whether it be an update or create, because I don't know. The move may be there. I don't want to lock it in and just update, because what if I'm sending it a new move that's not there yet? And then we want it to be created. But this defaults, okay, is the data that will be used. Okay. So this is just the way this method is set up. It's going to take in that arguments that it's going to update or create and run it against this ID or, create an ID if there isn't. Okay, so it's going to go to tackle. It's going to look in our database, see if tackle's there. If it isn't, it's going to create it. If it's there, it's going to update it. And then incoming move IDs we're going to append the move ID. Where is this move coming from? Right here. So this is a little complex trying to walk through these, but how you set this up is going to be the same every time. So this move is what we're assigning to all of this that gets created or updated. So we're going to take this empty list that we made up here, and we are going to add the ID of this move that was either updated or created and just stick it in this list. And apparently this method also returns a Boolean that tells us if the object was created or updated. So if it was created, then we'll just add it to the Pokemon's moves. So here, if it's created, we'll just instance and then moves add a move. Because instance.moves is going to be that list under our Pokemon model here. Okay, so
basically it's taking all the moves that's in that body, right, in the request, and it's just going through those and putting them in the incoming move IDs, correct?
Yes, if it hasn't been created.
Or if it's in there already,
Or
then it just
sorry,
updates it with what
if
with
it's
what
in
it
there
knows.
already. Yep. If this move's already existing in our database, then it comes and sorts right here.
Now,
Um,
when you say database, though, do you mean the body? As in the request sends in, here's the moves I want updated, moves equals this data.
no, I am saying in the Postgres database holding all the moves that already exist. So this is going to go back and check our database and say, hey, do you have a tackle saved in it somewhere yet? And then if it does have tackle already there, then it's going to add it to this incoming moves. Because at the end, then we're going to just add it on to this moves, I guess. Create updated. Let's see. No, where is it? Okay, incoming data. So anything that's for move ID and current move IDs, which is, where do we have that here? Okay, wait, let's keep stepping through so I can see this circle of life here. Okay, the update will return a Boolean created. So if it was created, we're gonna just add it to the Pokemon moves. Okay, so any move that is new will get created and slapped on the Pokemon right away. The rest of them that are already there in the database is going to be held in this list for a minute. So it's going to go through and do that whole thing. At the end, it looks like we create an updated list of the current move IDs. So here we're taking for the move ID for move in instance.moves.all. So that's going to be anything that is saved to this Pokemon right away. Any new created move gets added right away to it. So for the instances are Pokemon. So for every move that already exists in this Pokemon, get the ID.
Isn't that outside that for loop, though? Or is that not supposed to be?
Yes, yes, it is.
Okay.
It's the next step. So we're moving through first and we're sorting. We're basically sorting between moves that exist in our database or moves we have to create right now.
Okay.
And so moves that exist come and hang out here. Moves that are created just get added to the Pokemon. And here, now our current move IDs, now we're saving those IDs from the Pokemon. So now we disassociate any moves that are not in the incoming data. Where does the incoming moves go? Right here. Okay. So use the move ID. Move data. Defaults move data. Trying to see where these existing moves get even added on the Pokemon. This is the very last step. This is going to go through and look at all the current moves the Pokemon has. And if a move ID is not in incoming move IDs, then we're going to get that move and remove it. I thought this was going to be a short lecture. Let's see. Okay, so it must be something with this move. Move objects, update or create. We make the moves. Okay, and then we add it on. It's existing. We put it incoming move IDs up there. And then, oh, no, that's not what I'm thinking of. Okay, so now we add And created instance dot moves dot add move. Hmm. Okay, I see now. So we don't have to add, of course, we don't have to add the incoming move IDs to the Pokemon because if we don't create it, that means they're already on the Pokemon and we just have to update that move with anything we send it. So this method will handle that right here. And we're just kind of hanging on to those up here because we use it later. So let's see, come down here. We'll look at our little handy. So he has Tackle and Vine Whip. I'm going to send in Tackle and Razor Leaf. So when it gets to this first one, it's going to look and say, okay, if there's an ID, like if this move already exists in the database, then just update it. Okay, so it does. It already exists, or yes, this move I send in, this move I send in, Tackle, I sent it in. It already exists in the database because it's right here. So it's going to update, and then it's just going to hang on to that ID for later use. The next one, I send in Razor Leaf. It tries to find the ID of Razor Leaf, and it's going to be like, there is no ID in this move objects here. I'm going to go ahead and create that. So we'll create that Razor Leaf. And when we create Razor Leaf, we're going to also just, since if it's created, it will give us a Boolean. We're going to add it to the Pokemon's moves. Okay, so now let's get back here. Wait, where'd it go? Okay, so now we're down here. We've got Tackle kind of waiting up here. The ID is waiting in incoming move IDs, and we have Razor Leaf already created and added to our Pokemon. Now, what do we want to do? So now we're going to grab all of the IDs that are currently on our instance. So we're going to grab, currently on our instance is going to be Tackle, Vine Whip, and Razor Leaf, because we just saved Razor Leaf to this Pokemon, correct? So all these IDs will be associated with this Pokemon. Now we're going to look through those IDs and we're going to say if that ID isn't in incoming moves, delete it off the Pokemon. So Tackle was something we sent in, or right here, Tackle something we sent in with the request. So it's going to be like, is that in our incoming move IDs? Which it is because it existed and we saved it in that list. So it says, okay, we'll leave that on the Pokemon. Razor Leaf, is that on the Pokemon? It'll be like, yes, it is, because I just created it and added it to the Pokemon. So now it's in my current move IDs list. And then it comes down to Vine Whip and it says, okay, is this still on my Pokemon? And it will look back in that incoming move IDs up here that we saved, which in our data that we passed in, we did not include Vine Whip. So it's going to be like, no, I don't have Vine Whip in this list. Let's go ahead and grab it and delete it. So that's what that's doing. Do we follow the story? It's kind of a roundabout way. Well, not roundabout. It's how we have to handle it. We have to have a way to store the things coming in, and then we have to have a thing that pulls all the moves currently on it, and then we kind of compare lists and say, okay, what should stay, what should go? and then take off things that should go. Okay. I will keep moving along. If you don't grasp that fully, that's okay. Again, this can just be grabbed and altered to whatever you're kind of working with. This here is on our many-to-many relationship, but it would work with a foreign key relationship as well. Anything that takes in an ID and is associated with something else. Okay, so that was update. Let's see. So are we done with our update, do we think? Should be, because all it is a serializer that's handling that update request for us. So let's see. Yep, we have, oh, what's that? Oh, it's our model with some Dunder methods, views. That's what I was going to look at. Okay. Oh, no, it's not all we had to do. What do we have to do next? I'm looking at my views.
We need a put request.
Yes, we need our put. So we wrote the serializer, but we still haven't used it yet. So we have our get Pokemon. We have a get for an individual Pokemon. Now we're going to do a put request, which is pretty much like a get. We're going to have a request we send in and an ID. And with this put request, first thing we want to do, because we're going to send this back to the serializer, our serializer expects an instance of a Pokemon and then data that we're sending it. So to get that instance of the Pokemon, we're going to take the ID and get that Pokemon, just like we did here. Now we can run our serializer. Is going to be still the Pokemon serializer because we are overriding all those methods in there. We're going to give it that Pokemon instance. And the data is going to be our request data. Okay. And next we need to do check if our serializer works, if all the data coming in works. So we're going to check and make sure that if that is valid. So if the data being sent in works with our serializer, then go ahead and save everything that we just did within that serializer. And then we're going to return our response. And it's going to be our serializer data. If that doesn't work, then we want to return a response. Let's see, we're going to do errors and a status code. We like to return status codes so people understand kind of what went wrong. And a 400 is the typical bad request, as it says there. So it means that whatever people sent us to our endpoint isn't going to work with our endpoint. Try again with something else. So then they know it's on their end, their mistake that they need to fix and not our endpoint's mistake. Okay, so we're going to save that. We're also going to put in our delete as well right now, because with our nested model, it doesn't change right now. However, you need to realize that when you do, let's see if we can read the README here as well, like it says. So Django's operation handles the removal of any model automatically by default. So this will delete the Pokemon. But then we also have the onDelete parameter that we used to set in our relationship fields. If we look back under here in our models, we don't have an onDelete for this one. Can anybody tell me why that might be? We had onDelete with our foreign key, but we don't have one on our many-to-many field.
Is it because that's an intermediary table and it's relying on two separate, so
Mhm.
yeah.
Yep, exactly. There's nothing in the move model is going to be touched by a deletion of this relationship. It's just going to simply go to that intermediary table and take out the two IDs that are relating to each other, and that's it. So the Pokemon, um, well, if we delete the Pokemon, it'll go away, but the move will still exist because it's in a separate table. Coming back to the README. So, but with the foreign key, we do have to do an on delete. And we can see here, this kind of explains some of the different um, ways the deletion is handled, depending on what you put in that on delete parameter. So usually we have done cascade in the past, and that will delete the object containing the foreign key or the field. We could see if it's set to protect, then it would prevent deletion of the reference model. So let's say move was just a many to one type thing, a foreign key relationship. If I do on delete cascade, if I delete the Pokemon, the move would also get deleted as well if I set to cascade. If I set to protect, the move would stay, but it would just not have a relationship to anything anymore. So it'd just kind of be hanging out there, waiting for something to associate with it. Let's see. So if you try to delete it on a protect, it will go ahead and raise a protected error. So this is where we have our set null, set default. So if you delete, you can also set that field to be null in the referenced object or set a default. All things you can read about in the background. Like we said, this does not apply to many because of the intermediary table. So currently, if I do this delete, which I'm just literally going to copy and paste because it's super easy, we're going to get the Pokemon and delete it. The move is untouched and it's fine. And we're going to start testing this all and seeing. So we got our endpoints already existing in our URLs because if we go to an ID, it will run selected Pokemon, our view, and we can see selected Pokemon has a get all, get the individual Pokemon. It also has an update the Pokemon now, and it has a delete the Pokemon. So let me run, I don't think my thing is Docker compose. Oh. Okay, and then we are going to Python run server. I don't think anything's up and running. Okay, cool. So now I'm just going to go to the browser to make it even easier. We're going to visit a Pokemon and make sure I even have one in the database right now. API. Let's look at one. Okay, I do. We can tell what we have in the database by going to all. It looks like I only have one. I have Charizard. Let's use, okay, so if I go back, I don't want to mess with Charizard. I want Bulbasaur in there. So let's go back and look at what that endpoint is. It looks like I don't have a post down here, but I do have a post option right here. And that's under the all Pokemon view, which is in this empty URL. So I am going to go to the empty URL and do a post request where I'm going to send the data of the Pokemon and save it in the database, which you learned about yesterday. Let's go ahead and get to that. Where is it? Let's see. Okay. So here I'm just going to do it in the browser. Here's my README. I'm going to copy. Oh, it's here. This is the Bulbasaur instance that said should exist in our database. which is this. So this is the body. Did you guys look at Postman the other day when doing this, or did you just work in the browser?
Yeah, we looked at Postman.
Okay, so this would be underneath the body option is where you'd send this information. But in Django's little UI here, I can just put it under content and then do a post. And we can see it was good, it was created. Our Pokemon Bulbasaur is now in there in our database. And it looks like he has an ID of 5. So I'm going to pull him up now with 5. And we can see now I did the get request. I have a delete option, which means we do have a delete feature underneath that view. And then we have a put request button down here as well, which would let me alter this. So theoretically, if we did this correct, wrote our view correctly, I should be able to put in this information. So I'm keeping his name the same. I guess we could change it. Let's change it just to see. It's another oddish. Okay, we're gonna make it oddish now instead. And he's gonna have tackle, which was already there, and razor leaf, and that gets a new power associated with it. So now if I push put, it should change Bulbasaur's name to oddish and keep tackle and put vine leaf or put razor leaf on and delete vine whip because I did not put that in my request. All right, looks like I got a 200, which is a good. It says okay. And we can see now the name is oddish. Tackle's still there. And razor leaf has replaced that vine whip. There were some defaults for, if you're wondering why did we just send in power and name in our request. That's because we could, because if we come back under here, we can see not under there, it's under models, under moves, because we added moves. So we can see we have a default value for pretty much everything in here. So if we didn't send this in with our put request, it would just, or it would have the default values assigned to it if it was a new move. Okay, so that was the put. Now we're going to go ahead and do our delete, which should just remove the complete thing, but leave our moves. Okay, so we have tackle and razor leaf. We're going to make sure that tackle and razor leaf are still in our database after we delete it. So here we delete. Yes. Okay, so now it's gone. There's no Pokemon 5. I can't get this Pokemon. Come back, we see Oddish is gone. Hopefully my moves didn't go away because that's not what I told it to do. I said to just delete that association. So if we come here, oh, we can see I was testing it quite a bit earlier, but the most recent IDs, 9 and 10. Okay, so we can see tackle and vine whip are still there, which is what we wanted. That sucks that all these moves are in there, but we're going to fix that because I don't like that it's leaving these moves in here. I want it to just take them out when I delete the Pokemon. So we are going to rewrite that view to be able to delete not only the Pokemon, but I want to delete all the moves associated with the Pokemon as well. In this case, it doesn't make sense, but in some cases, depending on how your application works, it might make more sense to go ahead and remove everything associated with this object as well in this many-to-many. If you do the foreign key, you can do the on-delete cascade and it'll automatically remove them, but with our many-to-many, it doesn't because there's not a direct relationship. It's that indirect through a different table. So all we do in order to do that is we just throw in a for loop. We're going to do for move in, let's see, Pokemon moves dot all. We're going to just delete them. And then after we delete every move under the Pokemon, then we'll go ahead and delete the Pokemon next. That's all we have to do for that. So let's save it and we'll come back since I don't have anything else beside Charizard. Poor Charizard. He's gonna get, I'm gonna have no Pokemon anymore. What ID is he? Oh, 1. Okay, so we're gonna delete Charizard. So then theoretically this Psychic attached with it should also delete as well with our new view. So let's push delete. Yep, I want to delete that Pokemon. Okay. He's out of there. Will make sense by hitting that. Yep, there's nothing in all Pokemon. Let's go back to moves and we'll see if Psychic is gone as well. Which, yep, I don't see Psychic anymore. All right, done. That was it for update and delete. Delete's super easy. Again, with the foreign key, you have the on delete cascade to go ahead and remove any other associated object. With many to many, we have to be a bit more explicit if you want to remove those. But this, where's, oh, I'm under the view. Okay, this overwriting the update method. Definitely a little more in depth, but hopefully we grasped what it was doing with this. You can play around with it too, obviously. You can do your own, you know how to grab the validated data coming in the instance, and you can separate things by using a pop, which will pop up that information, and you can play with different ways of updating your instances. But the key takeaway is you need to update the main instance first, that is our Pokemon here, and then any nested instance information afterwards. Any questions? And again, you don't have to do nested information at all. You can definitely go ahead and grab the move ID and deal with it separately. You don't have to deal with it all in one endpoint, but this is just for ease because I wanted, for my app, I wanted to be able to go and send in all information at once, like we see in the README here. I wanted to be able to send in everything, not just a number here under moves. Okay, I will stop recording if there's no questions.